get it rolled on really quick. Morgan. Anna's not here. Alexis is not here. She's here. Rebecca's not here. Kristen's here. Kelly. Amber's not here. Barbara's.
Oh.
Mother, father.
You clicked backspace too much, I think.
Let's try that again. Cancel. Justin here. Maria. Ashley. No. Sean's not here. It's always easier to remember the dudes' names because there's only a few of us here. April. James is not here. Candace is here. And Samantha. Exactly half the class is here. WTH.
Alexis is sick. She texted me this morning.
Oh, she did?
Yeah.
So I'll get an email at like 9:30. That's usually her MO.
Probably.
Oh, by the way, I know class started a half an hour ago.
Yeah, she texted me at like 8. She's like, hey, I'm sick. I'm not coming in. I was like, alright, I'll tell him.
All right, so let's try this again. Okay. So this is that first module that has class information on it. A couple of people said that when they printed out the conversion chart here, when you click on it, when they printed it out, it cut off the bottom portion. If you actually click on this little blue hyperlink on top that says original file conversion table .docx, it will actually pull up a Word document that has the correct margins, so when you print it, it will print with everything on the same page. If you print from the previous page, this web page, that's what you're actually printing as a web page. So it will just, because web pages have that wraparound effect, so it will only print what's showing. And if that's all you have showing, then that's all it's going to be printed. So make sure that when if you decide to print that, which I would recommend, especially after today, because today is chapter 14 through 16, where we start doing a lot of conversions. So this is the basic chapter that sets us up for the rest of the semester for math. So make sure you have those conversion charts. I'm going to close the door here. So it's not so loud. So who here has done their forums online like they're supposed to?
Like half of them.
Mostly good. I would say about 50%. So
I didn't do the lookalikes and the lookalikes.
let's talk about them for a little bit here. Chapter 10, 13, we had medication administration, or this was a lookalike. I opened up that one for you guys today, sorry. When you're going into these forums also, if you right click on them and then open link a new tab, it works a lot better than clicking on it and waiting for it to bring up a new tab or window. Just if you were wondering or having any issues with web study pulling up web files. So what was this story about? Remember?
The nurse was throwing the medication.
Tossing the pills into
like,
the patient's face.
Like, it'd be like throwing popcorn up and trying to catch it.
Yeah. Maybe some of the residents enjoyed that. It was the highlight of their day, playing catch. But what do you guys think about that? Is that appropriate?
No.
Okay. I will tell you, working in the medical field, that you will meet some patients that you'll want to toss them from that far. And if you can actually toss them from the door, you'll even be happier, right? Does that make them feel welcome though? Does that make them feel appropriate? They feel like they've got leprosy, right? And they feel they don't want you know, they feel feel downgraded. What's that?
It's not like they got the plague.
Yeah, it's not like the plague. It's not like they got Ebola or something, right? So make sure that you understand that's not appropriate, okay? So, now the other thing that comes up is she would purposefully take naps on shift, okay? Who here has worked nights before?
I work nights.
Okay. You work nights, okay. Is it always easy to stay awake?
Yes. I was having more trouble on day shift.
Yeah, depends, yeah. If you're 22 years old, that's, I guess, a different part. If you don't have kids that you're chasing around 24/7. But I used to work, before I got this job, I would work, I would start my work week with a Wednesday night shift in ICU, Thursday day, airback shift for 24 hours, a Friday night shift in ICU, with a Saturday day for 24 hours shift, a Sunday night ICU and I would do that from Wednesday to Wednesday, okay? So can you imagine my sleep pattern by the time I got off of shift, okay? I did this so I could have a week off every other week, right? So luckily, most of the time I would get to be able to go to airback, and EMS stands for earned money sleeping, so I could sleep during the day, it wouldn't be a big deal. Every blue moon, I would have to fly. I'd get there to work and we'd fly all day, like to Albuquerque and Las Cruces and El Paso and everywhere. And so I'd go like 48 hours without sleep. Okay. But every blue moon, when I would come to that Tuesday night ICU shift, it would be literally impossible for me to stay awake. It'd be killer. So working a life like that, I have a little bit of sympathy for her on the sleeping, okay? Does that make it right? No. Okay. Every blue moon, I'd be typing, and next thing I know, I'd have my face on the computer, and then the nurse would be like, "Hey, your alarm's going off in bed too." I'm like, "Oh yeah," and I'd be awake, you know. But did I ever go make a bed, go curl up, tell everybody don't bug me, you sleep? No. Okay. So just make sure that you understand there's a difference between accidentally falling asleep and actually her going in and letting out her linens, putting her pillow together and laying down and sleeping, okay? So I do have some sympathy for those tired night shifts, but just make sure you look at both sides of it when you're making the comments. I see a lot of comments on, pull her license, how horrible of a nurse is she, you know? And I don't agree with throwing pills at somebody's face, ever. I tend to try to treat my patients like I would want to be treated, you know. So just remember that I have
Fear of germs.
Fear of germs, yeah. You know, my dad spent some time in a nursing home, but a rehab facility after he had a really bad stroke. He had first he had an ischemic stroke. He had prostate cancer first, and while he was under the knife, he had a huge ischemic stroke. So that made him go to a rehab facility, and then he got discharged from a rehab facility and was able to go home. So of course, when you have an ischemic stroke or a blood clot stroke, then you get medication called Coumadin. So he was on Coumadin, which thins your blood, and he ended up having the opposite kind of stroke, and a hemorrhagic stroke, okay, which put him in the neuro ICU for weeks, right? So then he had to go to a rehab facility again, and he had some nurses that were horrible nurses. And I'd go visit him, and he'd always say, "You're not going to be that type of nurse, are you? You're not going to be that type of nurse. You're better than that." And so it's those kinds of stories that like, oh, like that's not appropriate, ever. You know, treat your patients like that, even if it is a nursing home. Treat them with respect. So, the other one, the look-alike, sound-alike. Did you guys remember the premise of that one?
It was with the heartburn.
Heartburn medication. Okay. Usually it's called Pepsid. The only thing that kind of bums me out for this patient is Pepsid. We don't, in a hospital setting, we keep track of things by their generic names. We don't, when it comes to alphabetical order or anything like that, Pepsid would be not with the P's, it would be the F's, because the actual generic name for Pepsid is famotidine, okay? So we wouldn't even have it with the stuff, but it just, errors happen. And this one, unfortunately, was the medication she confused it with is a medication called pancuronium, which is a paralytic. Okay, so no, you cannot help me right now, Mr. Lawyer Man. Okay, so the half-life on pancuronium is the longest of the paralytics. If you give pancuronium, they're going to be paralyzed and unable to do anything for 2 hours. Okay, they have no muscle reaction. Their eyelids don't blink.
Crazy.
The only thing that they have is their brain. So she gave him that pancuronium instead of Pepsid. So he literally sat there in terror while he was fully awake, fully conscious, and not able to breathe or move or call for help or anything.
Couldn't breathe.
That's what happens with pancuronium. It literally paralyzes every part of your body except your brain. You're fully conscious, alert. You have full receptors. You have pain. You have everything. You just can't move, breathe, or do anything. You just sit there. So, what a horrible, horrible, horrible way to die. Right? Now that right there, when we have patients that we decide that we need to take over their airway, they're having difficulty breathing, we'll actually give them a sedative first, and then we'll give them that medication so they're not awake for that experience when we stop their breathing. The reason we give them that medication is because when we intubate them, we stick a big blade in their mouth and we stretch their jaw out so we can see their vocal cord and stick a tube down their trachea, okay? Very painful process, and your body's natural response, even when sedated, when you get someone pulling on your jaw like that, you want to bite down. Even that's like an innate, you can't control it, okay? Even if I consciously said, all right, yeah, stick a blade down my nose, let's see what happens. My body's natural response is like, oh, that's a bad idea, stop it, you know?
Yeah, reflex.
Right, and you have the gag reflex and everything. So we give them these medications to help so we can do these procedures, okay? And we have lawsuits, you know, not we meaning just healthcare providers in general, not me, but we have lawsuits where we've given medications in the wrong order. We've given the paralytic first and then given sedation so the patient remembers parts of the procedure. Legally, that's considered battery, and we can be sued for that. So yes, they took legal action against this nurse, and they want to take more legal action against this nurse.
Arizona doesn't have battery, so it'd be assault.
Assault, yeah. So assault and battery, whatever they want to call it, in whatever state you're in. But point being, yeah, horrible situation. The point that I think that some are not getting is, do you think that that nurse planned on murdering a patient that day?
No.
No. Do you think that she's ever going to live that down? No. Did she miss some of the 5 rights or 7 or 6 rights that we learned about last week? Yeah, she did. She missed several of them. And that's what led to her med error. But being a person who's had, thank goodness, in comparison, a small med error, or 2 small med errors, okay? That feeling I had after the med error, even though they really had no patient harm at all, actually they probably benefited both patients, okay, my med errors, I was sick, and I can't imagine what it would feel like to be like, oh yeah, and by the way, the patient died an agonizing death. Wouldn't that be just horrible? So you guys coming into the field, yes, I think there needs to be just action. I think that we need to make sure that this stuff needs to happen. But you know who I think is just as liable? The hospital. Why is pancuronium anywhere near Pepsid? Why is it not in a covered, container? How did this happen? A root cause analysis should be followed, and then the hospital should answer some questions. How did this happen? Yes.
That was my big question. I didn't even understand why it would be there for a nurse on the floor to be using, even though it was a locked cart, especially after you're
We locked all our carts.
how you use it and that kind of thing, but why would it be there, and who is responsible for stocking those carts?
Right.
Is it the charge nurse of that floor?
Mm-hmm. It's the pharmacy tech. It's a person who gets a
Okay.
couple semesters of school and gets a certificate. That's literally who stocks the machine. Does that mean they're not capable? No, they're perfectly capable. But errors do happen. I told you my look-alike, sound-alike medication. At least in my case, the first 5 letters were identical, right?
Yeah.
But goodness, I would have murdered my patient that day if I wouldn't have checked the 3rd time. The hospital I've worked for previously, they had an event where they had, in their locked container, they had narcs and paralytics and drips by each other. And they grabbed the wrong bag and hung it and almost killed the patient. That patient ended up being just fine, but root cause analysis followed, instead of just clobbering the nurse and saying, hey, we're going after you. A root cause analysis followed, and they found out, hey, the hospital was just as big of an error as the nurse. Why was these medications sitting next to each other? Especially high alert medications, okay? Like a paralytic. That one dose will kill you, okay? If you're not ventilated and sedated and appropriately taken care of. So make sure, $2,800 seems like a small fine, but the emotional torture that will happen for this nurse for the rest of her career, if she even decides to keep practicing. She works on the same floor at the time of this event, this came out, but I'll bet you money she no longer works there. I have a friend who had a mid-air and it ended up in a patient compromise. And it ended up being, a lot of it being, they did root cause analysis, and part of it was the hospital's fault. So yeah, she had to pay her dues, but she still didn't lose her license. She was able to practice without any restrictions. But that anxiety that she got from that med error that caused patient harm made it so she could no longer practice as a nurse. She could no longer handle being at the bedside. Like, she just had anxiety attacks for months. So she had to quit. So she went back to school to be a nurse practitioner, so she can just write the prescriptions and not have to be responsible for looking at every single thing and be the one that's responsible giving these things.
And she's probably really good at what she does.
She was. She's spectacular. She's very intelligent. Very intelligent. But she had one slip up. And it ruined her nursing career. So gave her a good reason to go back to school. But do I think less of her? Nah, not at all. Do I think of less of this one? No, not really. What a horrible news she had to get. Like, hey, that patient you medicated is dead. Can you imagine that? So, make sure you realize both ends of it, because you guys are going into this field. The most common term is that nurses eat their young, right? We're the worst. We are the worst profession for it's backseat drivers or Monday morning quarterbacks after something's went down. So make sure that you keep that in mind. Okay, try to really think what was going on in that situation, and don't blame just one person. There needs to be more looked at. We need to look at, what did the hospital do in this case? Where were these really actually stored? Because we lock all our medications. Everyone's like, oh, it was in a locked cabinet, like they kept it separate or something. We keep all our medications locked up, right? So remember that when you're making judgments on these forms, okay? I just figured I'd mention it a little bit. I enjoy you guys making comments and going back and forth. I read them all, so just to make sure. I just police it. I only make comments every blue moon if I need to. So.
And those are on the forums?
Mm-hmm. Any questions about the homework or anything that's come up that I need to do on the board before I get started on the lecture today? Anyone? Bueller. So what I'm going to do first is I'm going to go through this PowerPoint. The PowerPoint maybe. Covers chapter 14 through 16. There's multiple ways to do calculation conversions or conversion calculations, tomato. So this PowerPoint covers all of them. It covers a couple examples, but the last couple slides are dimensional analysis. And dimensional analysis, I wish that this turned off the front and back out instead of side to side, because that just makes it so you guys get nice and sleepy at 9 o'clock in the morning.
The blinds in the back, so they should still open up.
Crack the blind a little bit, but then that's just shining directly on. There's no happy medium. Anyways, so dimensional analysis is what I would prefer you guys to use. It is the easiest, most spell-safe method. And once you get it understood and put it into practice, it can answer any conversion question for you. Whether it be how many milligrams per ml am I going to give, or whether it be how many fish are in a bucket and how many buckets I need to hand over to somebody. Right? It can handle anything that includes a unit, a measure within a volume. Okay, so that's why I like dimensional analysis.
Is your thing recording?
Yes, it is. So I'm gonna go through this. After this, I have some videos that kind of explain dimensional analysis a little better. My little cookie thingamajigger. Try that again. There we go. Okay. So I have some videos that we'll watch after this that use dimensional analysis, and then we'll do a lot on the board today, so that way you guys can hopefully wrap your heads around it. So there's 3 steps to dosage calculations. We have the ratio proportion method first. First, we talked about this a little bit a couple weeks ago, but you have to convert all units to the same system and all units to the same size. Okay. So first, we have to make sure that yes, we are all in the metric system. So it needs to be all some sort of gram, milligram, whatever, milliliter, and then we need to make sure they're all the same size. So if I need to make it from grams to milligrams, if that's what I'm doing the math for. Okay. Number 2 is sometimes the hardest thing that we have to remember is think about it. Estimate a reasonable amount. Okay. So commonly I get these when we start this. Okay. And everybody starts using their fancy math and plugging things out, and then I get an answer that says, today I'll give my patient 1,000 tabs of Tylenol. Are we ever going to give a patient 1,000 tabs of anything? That's like 2 bottles, right? That's like 2 Costco bottles, right? Is that ever appropriate at one time? No. So think of a reasonable amount, okay? So the answer probably should have been 1,000 milligrams or 1 gram, right? Not 1,000 tabs of anything, ever, okay?
Or 1 tab.
Yeah, or 1 tab, or 2 tabs, okay? Let's make sure you think about it. Estimate a reasonable amount before you even get started. Then you calculate it, okay? And this is using ratio and proportion. We have the dosage on hand with the amount on hand, okay? Dosage. So that would be like 2 milligrams per ml. And I'll have or 500 milligrams per tablet. That's what's available to you. Dosage desired would be the 1,000 milligrams, and then how many tabs am I going to give that patient? Okay, this is just breaking into it. So here's an example. Okay, I have clindamycin. Here's my cleosin phosphate or clindamycin. Okay, 300 milligrams per 2 ml is what's available. Okay, my order is for 0.6 grams. First of all, is grams and milligrams the same thing?
No.
No. Okay. It just shows my order and my supply there. So first, I got to make it convert it to the same unit. So I need to make sure that I have milligrams. Okay. First. So using this conversion factor, I have 1 gram is to 1 milligram, 0.6 grams to X milligrams. Make sure that if you're going to do a conversion like this, that you have the same unit on top and the same unit on bottom. So milligrams are on top, milligrams are on bottom. Cross multiply and divide. That will tell you that 0.6 grams is 600 milligrams. Also available and way easier to do is just move your decimal to the right 3 places to go from grams to milligrams. That way you don't have to mess up your math here. You just know that I just need to move it to the right 3 places for 600 milligrams. Okay? So now we have like units. We know that there's 300 milligrams per 2 mLs, and we know that my order for 600 mLs, so I am going to give more than 2 mLs, right? This is a little bit of common sense, using common sense for your math, okay? So I know that 600 milligrams is, if 300 milligrams is 2 mLs, then 600 milligrams will be 4 mLs, okay? So doing that math, 300 milligrams per 2 mLs, making sure that it's milligrams per ml. And then I talked about this too, that this is why I want you to put milligrams per ml, not milliliters per milligram, okay? For here on out for math. 600 milligrams for x mLs. Cross multiply and divide, getting 300, x equals 1200. Doing my general algebra where I take 300 divided by 300 to get x by itself to get my 4 mLs every 12 hours, okay? This is, by the way, this is how I want you to show, if you're going to use this method, you don't have to put the arrows, but if you put 300 milligrams for 2 mLs, 600 milligrams for x mLs, and then write 300 x equals 1200, and then write 4 mLs intravenously, that is plenty work for me. As long as I can see that this is the method you use, this is the step that you took, I will let you, I can tell that yes, 300 divided on both sides will get you 4 mLs, okay? But you need to make sure that you show your work. I do not like just answers. Some people have figured that out with the half credit they've been receiving, okay? This is the formula that they teach in the skills lab for nursing school. This formula right here. I like it for quick math, but I don't like it for ICU math, which is our last 3 chapters where we actually do drip calculations. Okay, so this works for quick math. If you want to learn a formula, this is a good formula. But I would prefer dimensional analysis because dimensional analysis works for every problem that we will do for this whole class. Okay. So, using this formula, this is the D is the dosage desired, or what's ordered by the doctor, so D for doctor. H is the quantity on hand, or what's available. And then Q is the quantity or unit of measure, tablets, capsules, mLs, whatever that vehicle that's going to be going into the patient. So, let's say here, I have an order for 0.375 milligrams PO of a drug, okay? My tablets are 0.25. Using my little fancy dancy formula here, I can see that I'm going to have 0.375, which is my order, see, over what's available, 0.25 per tablet. Make sure that these two right here go together, 0.25 per tablet, okay? If it was 0.5 per 2 tablets, then you would see 0.25 and a 2 there, okay? And then doing the math, 0.375 divided by 0.25 multiplied by 1 gets you 1.5 tablets, okay? That is a really quick method for easy solutions. Like if I'm giving PO Tylenol to a pediatric patient and it's a syrup, that works just fine, okay? But when you start actually adding 2 units of the measure, like where you have an actual volume over a certain amount of time, which is IV drips, this really doesn't work that well. Here's the second formula. This is the dosage weight or dose desired, which would be your doctor's dose, and then the stock weight, so over the dosage volume, which is what the doctor ordered over the stock volume, okay? We'll see here. So I have my order, 7,000 units of an intramuscular drug, right? So what's available is 10,000 units in 2 mLs. So if you guys are wondering, the only medication that comes in this form is heparin, okay? So I have my dosage ordered, the doctor's order, remember the D. So I have 7,000 units over the 10,000 units available, stock, right? XML, because that's what we're trying to figure out. We don't know how much we're going to give, so the XML is my dosage desired. desired, my volume desired, right, over what's available to me, 2 mLs. If you notice on this formula, units on one side and the volume on the other side, okay? This is a kind of a version of dimensional analysis that you'll see kind of some similarities here in a little bit. So doing that cross multiplication and division, we have 10,000x equals 14,000. Crossing out, doing our algebra, we know that we are going to get 1.4 mLs. Okay? This way, to me, is one of the more confusing ways, because I don't remember DW and DV and SW and SV and all that business. Okay, so that's why we're skimming over it briefly, because it's confusing and you'll end up with math errors. So if you have different units or systems of measure, make sure that you choose the identified equivalent and convert to what is ordered to the same units of system measure as what is available. Okay, so if I have an order for 2 teaspoons, or if I have something like let's say here I have grams available, but what orders is milligrams, make sure I do that conversion to get to, so I have like units, milligrams. That's all that is saying. And then use whatever formula you choose to calculate the dosage to administer. This is my favorite way, dosage calculation using dimensional analysis method. If you've taken chemistry, I think in 138 they start using this, and this is dimensional analysis. Okay, this is the same thing that we use there, using those, crossing out all the units, and it's just a way that we use simple methods to manipulate units. Okay, we can cancel all unwanted units by arranging it all in one way, with leaving only this right unit behind, so we get the right answer every time. Okay. Supposed to be a common sense approach, but when we get started on it at first, you'll be like, this is not very common sense. Okay. But that is the idea, because once you start understanding the concept of it, it's really easy to use. Okay, and it makes it so you don't have to memorize any fancy formulas. You have a unit that you start with, and you have a unit that you end with, and you use your conversion table that you have there that you printed out for the steps in between, and then you'll end with the right thing every time. Okay. So we were talking about conversion factors. You have your sheet there. So like 1 gram equals 1,000 milligrams, 1 grain equals 60 milligrams. And so when we start this, you'll have to understand that your math will get a lot faster if you memorize those units, okay? But you have to use those units, those conversion factors, for every step of dimensional analysis. Okay? And remember we talked earlier about how 1/2 equals 2/4, okay? They're the same total value, just different numbers, right? And that's reducing and moving numbers around. Does it change the actual end result when it comes to value? No, we've just changed the numbers. And that's what we're doing here with dimensional analysis. We're just going through the units. We're not really changing any values. We're just converting them to a new unit. That's it. Okay. Just remember with dimensional analysis, sometimes depending on what we're looking for, we'll have to flip things around. So if 1 kilogram equals 1,000 grams, we know that 1,000 grams equals 1 kilogram, right? That's the same thing as if I have 1 kilogram equal 2.2 pounds, 2.2 pounds equals 1 kilogram. I can write it vice versa for what I need for dimensional analysis, okay? Because they mean the same thing, right? It's just I'm saying it different ways, different order, okay? Make sure, we have ratio and proportion where you could use the colons and that kind of stuff before, and do means and extremes and all that BS. For dimensional analysis, everything has to be in fraction form, okay? So no more colons, it's all in fraction form. And how the fraction is written depends on the unit you want to cancel or eliminate to get the unit desired. Okay. So first we want to identify the desired unit, and then we're going to identify our conversion factors or equivalents needed. Then we label all the factors. So make sure you have all your labels, all those unit labels, milligrams, mLs, everything in the appropriate way, because if you don't have those in there, this doesn't work. When you write them all out, then you can cancel them off cross them off. And if the last thing crossed off is what you're looking for, then you know you set up the problem right. That's how you check your work. When you cross off all the units, your last unit left should be the unit you're looking for. And this makes a lot of nonsense until we do it on the board, okay? So I have 1.5 grams equals how many milligrams? We know that we can move the decimal place over. That's an easy fix, right? But using dimensional analysis, we can do the same thing. So I know that I'm looking for 1,000 for milligrams, right? And I know that 1,000 milligrams equals 1 gram, and I know I have 1.5 grams, okay? So what do I want left over? I want milligrams. So knowing that, I put 1,000 milligrams over a gram, and then I put 1.5 grams on top. What crosses out? My grams. What's left? Milligrams. So did I set this up right? I know that I did because my only unit left is milligrams. So I could take 1,000 times 1.5 divided by 1, and that gets me 1,500 milligrams, which is the right answer. Okay. So let's do it with some medication. My order is 40 milligrams PO daily. My available is 20 milligrams. Okay. So I know that I need to know how many tabs to give my patient. So I know. Look at this. This is a conversion factor, is it not? It's not what you're used to. It's not a 1,000 milligrams per gram or 2.2 pounds. But any unit of measure with some sort of volume, be tab, whatever, is your conversion factor. So I have 20 milligrams per tab. There's my conversion factor. I have 40 milligrams. So I put, knowing that I need tabs, I make sure that that's on top with milligrams on the bottom. So that way when I put 40 milligrams over here, guess what? Milligrams cross out, leaving just tabs behind. So when I do the math, 1 times 40 divided by 20, look what I get, 2 tabs, because that's the only unit left over. Okay, let's do some of these on the board. Well, first, let's do the YouTube video. Today, maybe. Got little jams going here. Hey.
Welcome to Chemistry Solutions. This tutorial is on dimensional analysis. Dimensional analysis is often a tricky concept for students to get, but it's a very important one and one that you'll use throughout all of your chemistry classes. Dimensional analysis is the process we use to convert a value from one unit or set of units to another. Some important questions to ask yourself when doing a dimensional analysis problem are: what are the starting units? What are the units that you wish to obtain? And what are the conversion factors that you can use to get from the starting units to the desired units? In dimensional analysis, you always use conversion factors to get from one unit or set of units to another. And conversion factors are fractions where the numerator and the denominator are an equal quantity expressed in different units. Because the numerator and the denominator are equal, you can also express a conversion factor using its reciprocal. So if 1,000 milliliters is equal to 1 liter, you could write that as 1 liter over 1,000 milliliters, or 1,000 milliliters over 1 liter. Because those two values are equal, the value of the fraction, or the conversion factor, is 1, regardless of the direction that the conversion factor is written. Let's try a problem. If Tim is 6 feet tall, how tall is he in centimeters? First, let's start with the information given, 6 feet. We know that we need to use a conversion factor, and we know that we need units of feet on the bottom to cancel those units out. And I think it's helpful to put the units that we want on the bottom right away before we even choose our conversion factor. That way we'll write our conversion factor correctly and not accidentally flip-flop it. So let's look at some conversion factors we have available to us. We can see that 1 foot is equal to 12 inches. We already have feet on the bottom, so we know that we need to put inches on the top. This allows us to cancel out feet. And if we were to stop this problem right now, we would have an answer in units of inches. But the question is asking us how tall Tim is in centimeters. that means we'll need to use another conversion factor. Just like I did the first time, I can set up my conversion factor with inches on the bottom because I know that I want inches to cancel out. Then looking at the conversion factors I have available, I can see that 1 inch is equal to 2.54 centimeters. Because inches is already written on the bottom, I know that 2.54 centimeters must go on the top. This allows me to cancel out the units of inches. And now that inches are canceled out, I'm left with units of centimeters. So to finish solving my problem, I'm going to start with 6 and multiply by every number on the top and then divide by every number on the bottom. This gives me an answer of 183 centimeters. Let's try another problem. 1 gallon of milk is equal to how many milliliters of milk? First we start by writing our given quantity, which is 1 gallon. And we also need to note that the units we wish to obtain are milliliters. So we know that we need to use a conversion factor, and we know that that conversion factor needs to have units of gallons in it somewhere. We also know that we want to put the units of gallons on the bottom, so the gallons from our starting value and the units of gallons in our conversion factor will cancel each other out. Let's look at the conversion factors we have available to us. We might see that 1 gallon is equal to 4 quarts. Because we put gallons already on the bottom, we know that 4 quarts needs to go on the top. This allows us to cancel out the units of gallons. Because we haven't yet obtained units of milliliters, we need to keep going. And so we need to use another conversion factor. This conversion factor will need to have units of quarts. And similar to our last step, we'll want the units of quarts to go on the bottom so that they will cancel each other out. Looking at the conversion factors that we've been given, we can see that 1 quart is equal to 0.946 liters. Because we already have quarts on the bottom, we know that 0.946 liters must go on top. This allows us to cancel out the units of quarts. But we're still not in milliliters yet, so we need to do at least one more step. And so we're looking for another conversion factor. And to make sure we don't write our conversion factor the wrong direction, it's always helpful to write the units that you need to cancel out directly on the bottom. So we know that we want to cancel out units of liters, and so we know we need a conversion factor that has liters in it, and we'll write the liters on the bottom. Looking at the list of conversion factors that we're given, we see that 1 liter is equal to 1,000 milliliters. And because liters is already written on the bottom, we'll write 1,000 milliliters on the top. This allows us to cancel out liters. Now, in order to finish the problem, we'll take our 1 and multiply by all of the numerical values on the top of our fractions, and then divide by all of the numerical values on the bottom of our fractions. This would tell us that 1 gallon of milk is equal to 3.8 times 10 to the 3rd milliliters. Now, looking at the conversion factors given, you might have noticed that different conversion factors could have been used to solve this problem, and you were exactly right. Dimensional analysis is a process used to convert something from one set of units to another, but there's no one correct path to get from one set of units to another. As long as you use appropriate conversion factors, there's often many paths you could take to arrive at the correct answer. Let's try this problem again using different conversion factors. Again, we start with 1 gallon. We know that we'll need to use a conversion factor and that we want gallons to be on the bottom. And the only choice we have from the conversion factors that we're given here is that 1 gallon is equal to 4 quarts. So we put 4 quarts on top of our conversion factor, and that allows us to cancel out the units of gallons. In choosing our next conversion factor, we know that quarts needs to go on the bottom in order for the units to cancel out. But you might have also noticed in our conversion factor choices that 1 quart is equal to 4 cups. So for this conversion factor, we have quarts on the bottom, and we'll put 4 cups on the top. This still allows us to cancel out units of quarts. If we were to stop our problem right here, we would arrive at an answer with units of cups. And because the problem is asking us for milliliters, we need to go one more step. So again, we'll use another conversion factor. Cups is the units that we want to cancel out, so we know that we need units of cups on the bottom. And then looking at our conversion factor choices, we see that 1 cup is equal to 236.6 milliliters. And we'll place the 236.6 milliliters on top. This allows us to cancel out the units of cups. And to arrive at our answer, we'll start with 1 and multiply by all of the numbers on the top of our conversion factors and divide by all of the numbers in the bottom of our conversion factors. And what you'll notice is that you end up with the same answer of 3.8 times 10 to the third milliliters, which lets us know that although one path may be more efficient than another, there are often multiple correct ways to solve a dimensional analysis problem. Let's make things a little more complicated. If a space shuttle can travel at 17,000 miles per hour, how many meters per second does it travel? Starting with our original value of 17,000 miles per hour, we know that we need to change this set of units to meters per second. So we'll need to change the units of miles on the top to meters, but this time we're also going to need to change units of hours on the bottom to seconds. And so we'll change each of those units separately.
So this is complicated now, but this is the same exact math that you will use when it comes time to do IV calculations with how many mLs per hour, how many micrograms per minute, and those kinds of things, okay? Because there's two factors that you're solving for. You're solving for a unit of measure and a unit of time, okay? So pay attention as good as possible, but we won't throw this at you quite yet, okay? But this is just kind of a precursor to what's to come.
Let's start with what we already know how to do and convert miles to meters. We know that we'll need to use a conversion factor, and in order for the units of miles to cancel out, we'll need to write miles on the bottom. We can then choose an appropriate conversion factor. 1 mile is equal to 1.609 kilometers. Because miles is already written on the bottom, we know that we have to write 1.609 kilometers on the top. This allows us to cancel out the units of miles. Then we choose another conversion factor to convert kilometers. We know that in order for kilometers to cancel, it must be written on the bottom. And then choosing an appropriate conversion factor, we can see that 1 kilometer is equal to 1,000 meters. And because kilometers is written on the bottom, 1,000 meters will be written on the top. This allows us to cancel out the units of kilometers. If we were to stop this problem now, we would have units of meters per hour. But since our question asks for meters per second, we now need to convert units of hours on the bottom to seconds. So we're going to need to choose an appropriate conversion factor. But because we want to cancel out units of hours and it's on the bottom, we need to have hours written on the top. Because remember, units that are the same on the top and the bottom can cancel out. Looking at our conversion factor choices, we know that 1 hour is equal to 60 minutes. And because we already have 1 hour written on top, we know that we need to write 60 minutes on the bottom of our conversion factor. This allows us to cancel out units of hours. And to convert from units of minutes on the bottom, we need to have a conversion factor where minutes can be written on the top. We also know that 1 minute is equal to 60 seconds. So we can write 60 seconds on the bottom. And now, because we have units of minutes on the top and bottom of our dimensional analysis problem, the units of minutes will cancel each other out. And now, if we look at the units we're left with, you'll see that we have meters on the top and seconds on the bottom, which is what our question is asking us for. So to finish solving our problem, we'll take 17,000 and multiply by all of our numerical values on the top, and then divide by all of our numerical values on the bottom. And we'll come up with an answer of 7.6 times 10 to the third meters per second. Thank you for watching Chemistry Solutions. We hope you enjoyed this tutorial.
Okay, that was one way, and we're going to watch one more, and then we'll start doing more. We'll do a bunch on the board so you guys can understand, and we'll work through them together, okay? If you notice, both these videos will use what we call scientific notation, where that's that 3.8 times 10 to the third and those kinds of things. That just tells you how many places you need to move your decimal place. So you would move, if it was 3.8 times 10 to the third, you would move your decimal place 3 places to the right, okay? Don't pay attention to that. Just write out the number how it comes up on your calculator. I don't expect you to use scientific notation. And we don't use scientific notation at all on the medical field. So it is fine and dandy for chemistry, but not for math for meds, okay?
So we can just write it like it comes.
Hey, I'm Nate. This is
Exactly.
my son Maxwell, and one of the things we do with Skype is add story time.
There we go.
Hey guys, Mr. Post, and in today's video we'll be looking at dimensional analysis again, trying to get some more practice in solving unit conversion problems.
And all these videos are available on the module for web studies, so you can review them, okay? And you can review this lecture also, so.
1 mile per centimeter using dimensional analysis, the valuable tool that we'll be using throughout the next several weeks. Okay, first step is to read the problem correctly, check it out, and I have 1 mile as a very important number here. That's going to be one of my givens, and I'm going to convert it to centimeters. Okay? So the first thing I want to do is read the problem well, and then list those givens. Right? So I'm given 1, and I want to write down mile. So I have a mile here. And on the other side, just a little reminder, kind of called a bookend. We're going to bookend the problem and remind us that we're going to be traveling towards centimeters. The conversion factors that we need are going to be down here. Now, these conversion factors are going to fill up the middle of the problem. Now, we're not going to use every single one of them. I give you a few down here to choose from. I want you to practice choosing the correct conversion factors. Now, 1 mile is going to be multiplied against or converted into another unit. Now, the unit I need to convert into will have a conversion factor that expresses miles in it. Because we need to leave miles behind and journey towards centimeters over here. Okay? In order to do so, I need to find my conversion factor that has a mile. And I find it down here, 1 mile and 5,280 feet. Now the question is, where does a mile go? Does a mile go on the top? 1 mile on the top? Or does 1 mile on the bottom? And the answer is, you need to write down 1 mile on the bottom and 5,280 feet on top. And the reason is because we need to cancel out the unit mile. And we can cancel the unit out when we divide by it. Now I'm in the unit feet. Miles is gone. I need another conversion factor to take me from feet closer towards centimeters. Alright, well, this conversion factor has been used, so that's out of the question now. What do I have to take me out of feet? Well, if I look down here, I really only have 2 conversion factors. I have 1 foot and 12 inches and 3 feet and 1 yard. Now, there's no other conversion factors though that use yards, so I'm not going to choose that. I'm going to choose 1 foot and 12 inches. Okay, once again, guys, the $1 million question here is where do I put the 1 foot? On the top of the problem, the bottom. If you go by the previous example that I've done, whatever unit that is right here needs to appear down here on the problem. So if feet is right here, I need to have feet down here to cancel out. So 1 foot will be on the bottom, 12 inches on the top. The unit feet is canceled out, and now I'm in inches. Now the problem doesn't stop yet. It doesn't stop because I'm in inches and I need to convert into centimeters. So I need another conversion factor along the way. Now whatever I know so far, I think you're seeing this trend here. Mile begins, mile is down below. I'm in feet now. Feet appears down below. I'm in inches now. So whatever I do, I know that I need to have inches on the bottom. Alright, well 12 inches on 1 foot's done, and I'm left here now with, let's see, I got 1 inch and 2.54 centimeters. Let's grab that one. Well, the 1 inch is going to go on the bottom, and the 2.54 centimeters is going to go right here. Inches are canceled out, and the problem is pretty much solved now. I just have to do the math. Okay, so the math is going to be, on the top, 1 times 5,280 feet times 12 times 2.54. And that will tell me how many centimeters I have here. So you're going to fill in this gap here with a nice little arrow saying we are done, and I just have to solve the math. And the answer that we're going to calculate is going to be 160,934 centimeters. Once again, guys, let's review the problem. You're happy to get this problem going. The first thing we did is read the problem carefully, and we saw that the givens were 1 mile and also converted to centimeters. So I wrote down my givens right here. That's my first step, write down givens. The second step was to fill the problem up with conversion factors. And the conversion factors came from the list of conversion factors that are down here. I then made sure, after step 2 was finished, that my units canceled out. I need to cancel out the units always. I'm always canceling them out diagonally going down. It's feet cancel out feet, inches cancel out inches. One thing I am not canceling out is the numbers. These numbers stay alive. I'm just removing the units. And I want you to finally see that the third step of canceling out my units, that centimeters was never canceled. I never cancel centimeters because that is where I'm going to. And lastly, the fourth step is a little calculation. Across the top was 1, this is the multiplication sign, 1 times 5,280 times 12 times 2.54. And just want you to recall, these lines here in the math problem are division. Now I'm dividing by 1 mile. I'm dividing by 1 foot. And lastly, I'm dividing by 1 inch. Altogether, my problem gave me 160,934 centimeters. Now, in the next example, what I'd like you to do is give it a shot yourself. You just make an attempt to solve this, okay? I want to convert 1 year into seconds. Now, I list no conversion factors here, mainly because these conversion factors are kind of common to us. You know, years, seconds, time, minutes, hours, days, etc. Okay? Press pause, try to solve this problem. I'm coming around and I'm going to solve it also. First thing I want to do is look at the problem, and I see here I have years and seconds. And I know the problem needs to be answered in so many seconds. And my problem is going to start off in a given of 1 year. Alright, so that's my first step. From there, I'm going to load up a problem with conversion factors. Well, if I'm starting off in year, I do know something now that I need to see the unit year down below. Now you have to choose what we're going to do with year. I'm going from a large unit such as years down to seconds. So I'm going to choose 1 year and 365 days. Awesome. The unit year has now been canceled out. The unit years is gone. I'm in days. Days does not match the ending seconds over there. So I can't have to actually improve this, and I need to cancel out days. I'm going to cancel out days by putting days in the bottom. And I'm going to say, in 1 day, there's 24 hours. Days have been canceled away from the problem now. Now I'm in hours. I've got to continue to break this down until I reach seconds. Okay, in 1 hour, I have 60 minutes. Hours have been canceled. Now I'm in minutes. I need to break myself down a little bit further to get to seconds. So in 1 minute, there's 60 seconds. And I finally cancel minutes out. Lastly, I don't go any further because these numbers, or rather these units, match. And as long as they match, I stop. My last step here is going to be calculate the problem. So let's calculate the problem. The problem is going to be 1 times 365 times 24 times 60 times 60. Okay, guys, quick little computation gives me, I got a lot of seconds here. I got over 31 million seconds in this problem. You know, there's more than one way to solve this problem. You're not locked into these conversion factors here. Maybe you wanted to choose days and weeks, months, etc. Months is probably not a good one to use because a month actually varies in days. So maybe you want to do 7 days a week. There's also different conversion factors of how many seconds there are, even in 1 hour. You could have gone that route. So my point is there's more than one way to get to this problem. But the key is the middle is loaded up with conversion factors that help you convert the given from 1 year all the way over here to seconds.
All right. So let's do some of these on the board. Did you notice that on the second one, he did not have any conversion factors on the bottom? Because those are all common conversion factors that we know. Okay? We know that there's 60 seconds in a minute and there's 60 minutes in a year. Well, I hope we all know that, right? If you're going to be in the nursing, I hope you know that. Okay. But that is why I like dimensional analysis, because I can look at your sheet and I don't know all those sheets. I don't know all those things. I can tell you a good chunk of them, but I don't have them all memorized. But I have important ones memorized, right? I know that 1 ounce equals 30 mLs, okay? I know that 1 quart has 32 ounces in it. I know that 1 gallon has 4 quarts, okay? Do I know everything in between? Do I know that 1 quart is 0.946 liters? No, I didn't know that only just because it came up on that video we just watched, right? but I do know the steps in between, so I can use what I do know and that I have committed to memory already to get from point A to point B. Will it be the most efficient every time? Probably not, but the fact is, I don't have to go look in Google to see how to get there. I can actually get there with what I already know using my own knowledge. So that's part of the reason I like using dimensional analysis. So let's go to page 269 in your book, chapter 16. And it has here, number 1, 8.5 teaspoons to ml. Okay. So I like to do it a little bit more similar to the way that the first guy did it. I mean, the second guy did it. When he has teaspoons on one end and he has mLs on the other. Your book shows you doing it like this, like the PowerPoint did, using
What page did you say that's?
269. Has your variable that you want to know here, and then you do your math here, leaving mLs on both ends. I really don't like that. I like the bookend approach where you go from beginning to end. Okay, so if you're wondering why I'm doing it that way, it's because this is what I prefer. So we have teaspoons, 8.5 teaspoons to mLs. So 8.5, I'm going to make that 8.5. A lot easier to use since we're using dimensional analysis in a fraction form, right? Oh, 8.5 teaspoons to mLs. Okay, so looking at your sheet, do I have a conversion factor that takes me from teaspoons to mLs?
Yes.
Okay. So do I want teaspoons on the top or bottom? Bottom. So I have 1 teaspoon equals what? 5 mLs. Okay. Crossing out my units. All right. Make sure that that focuses right on the. So what is my unit left over? mLs. So did I set it up right?
Yes.
Okay. So 8.5.
42.5.
Okay, 8.5 times 5 divided by 1 is 42.5 mLs. Okay? So if you're going to try to show this on your homework on the internet, that's fine. Okay? That's how I want you to show something, okay? I can visually take the slashy and turn it into this in my mind. I don't need you to try to. I did have some people last semester that would write it a line at a time and then underline and then tap so that they could line it, and it looked exactly like this right here, which was very impressive and made it easy to follow. But that takes a lot of time, and you guys have limited time for these tests. So make sure this is just fine right here. If you just put it in a linear fashion, see 5 mLs over 1 teaspoon, 5 mLs over 1 teaspoon is fine with me, okay? Just so I know that those cross out, leaving mLs, and you can do your math, okay? All right. Let's do another one. 46.4 kilograms. To pounds. Okay, so is there a conversion factor on your little fancy sheet of paper that tells me kilograms to pounds or pounds to kilograms? Okay, and what is it?
2.2 pounds per 1 kilogram.
2.2 pounds per 1 kilogram. So, what goes on the bottom?
Kilograms.
And 2.2 pounds. Did anybody have a hard time remembering that if I wanted to convert from kilograms to pounds, that I had to multiply by 2.2, or if I want to convert from pounds to kilograms, I had to divide by 2.2? It was common on some of the math that I seen. Can't recall if it was for this class, but there was a common misconception. They could not remember that. Okay, using dimensional analysis, do I have to remember that anymore? No. As long as my units cancel out, leaving me with the right unit, I know that I'm going to do the right math. So kilograms cancel out. leaving me with just pounds. So 46.4 times 2.2 divided by 1 is
102.08.
102.08 pounds.
Would you leave it at 08 or would you round it off?
If I some will say round it 2 places, some will say round it to 1. If I don't tell you, you can just round it to 1. That's fine, 1 unit. But some of them I will actually specifically say round 2 decimal places. So. Okay, let's do one more. 2 tablespoons, 2 mLs. Okay. So is there a conversion factor that tells us tablespoons to mLs on there?
Yes.
Yes, and what is that?
15 mLs per 1
15 mLs per 1 tablespoon. Okay. Which one goes on the bottom then?
tablespoon.
1 tablespoon. What goes on the top? 15 mLs, right? Make sure that you use all your unit labels because that is part of the way we do our math. So 2 times 15 is 30 mLs. Okay? Right? What if I didn't know that one? I didn't have my little fancy conversion sheet and I know that there's 5 mLs to a teaspoon and there's 3 teaspoons to a tablespoon, right? So look what I can do. 2 tablespoons. 1 tablespoon is 3 teaspoons. 1 teaspoon is 5 mLs. Tablespoons cross out, teaspoons cross out, leaving me with 2 times 3, which is 6 times 5, which is 30 mLs. I didn't even have to erase it. It's the same number, right? So that's another way I could have got there. Now that's an extra step. It's not as efficient. But if I could not remember all the conversion factors, because you're going to have to commit these to memory by nursing school. You don't have all you don't get to give a cheat sheet with you for nursing school. Okay, so if I couldn't remember all of those conversion factors, as long as I know some of them, I can still get from point A to point B. It might be a long, windy road, but I'll still get from point A to point B. All right. Enough of the generals, let's do some real medications here. All right, let's look at number 19. Order is for 0.5 grams PO Q12 hours, okay? Available is 250 milligrams per tab, right?
What page are you?
275, number 19. I apologize.
Oh, okay.
So what am I starting with?
Your order?
Your order, I can start with my order, 0.5 grams, right? Is grams and milligrams the same? Because available is in milligrams, right?
You'd have to change that.
So we got to convert that first. So what's going to go on the bottom? Grams to how many milligrams? 1,000 milligrams, okay? Because we got to get like units first. Okay, now I'm in milligrams because that's all the only unit left over. But I ultimately need to know how many tabs I'm going to give this patient, right? So what conversion factor am I going to use? Because it's not on your piece of paper anymore. It's on the order or on the unit.
250 milligrams per 1 tab.
250 milligrams, sorry for my sloppy handwriting, for 1 tab. What crosses out? Milligrams. So what is left over? Tabs, right? So did we set it up right? Now that we ended in tabs? So now I can do the math. So 0.5 times 1,000 is 500 divided by 250. 2 tabs.
Is that a reasonable answer?
And that's a reasonable answer. Am I giving 1,000 tabs? No, I'm only giving 2. So we know we did it right. Okay? I'm telling you, if you learn this way and get it down pat, and you'll have every opportunity for the next several chapters, it will benefit you. I was talking to Shalay the other day. She's the second. I replaced Shalay. Shalay was in this job before me, before she went to the nursing department. And she teaches second block over there, and she says she can tell a difference in the math answers and the results based off of people who understand and can use dimensional analysis, based off of people who use a formula method. Because if you can just remember dimensional analysis, you don't have to remember any formulas. And so she says it makes her happy because she really pushed dimensional analysis, and she called me to remind me to keep pushing dimensional analysis because she actually really sees a difference in the math results for her students that are in the program. And just remember, in the program, if you miss so many math problems on your tests, even if you have a 99% on every test when it comes to nursing content, if you're not passing your math, you flunk out of the program no matter what your grade is. So math is important, okay? Let's do another one. Oh, let's do this one here. So number 6 on 277, I have my order for 80 milligrams of thiamine. Okay, thiamine is available in 100 milligrams per ml. Okay, so what is my conversion factor that I'm going to use next? Do I need to do any conversions of units first? No, because I have milligrams and my availables in milligrams, so we're good to go. Okay, so what's my conversion factor?
100 milligrams.
100 milligrams per ml. What's available, right?
Yeah.
So what goes on top and what goes on bottom?
100 goes on bottom.
100 on bottom. Why is that? It's milligrams, and we want them to cancel, right?
Yeah.
What goes on top?
What ml?
So, looking at it, my request is for how many mLs am I going to give of this solution?
80
So I know
times 1 divided by
that I have mLs left. So 80 times 1 divided by 100 is 0.8 mLs. Okay. Is this, do I want this?
No.
No, that's a half credit for you. Because 80 mLs of this solution would be a toxic dose for this patient. Okay. 80 mLs would be a bad day. But
Because it only comes in a 2 ml.
yeah, it comes in a 2 ml vial. So if I have to get 40 vials to fill a dose, I might not have the right dose, right? All right, let's do one more, and then I guess you guys can go. Find a good one. All right, number 19 on 279. My order is for 0.4 grams. My available is 375 per 5. Okay, milligrams. Is milligrams and grams the same? No. So we got to convert it first. So what's my conversion factor?
1,000 milligrams per 1 gram.
So which is on the bottom?
1 grams on the bottom.
And what, 1,000's on top. Okay, so cross those out. So now I'm in milligrams. So now we can do some work. So what is going to go, what's my conversion factor and which one goes on the bottom?
375
375, so my available, right? 375 milligrams. Okay, is it 1 ml?
It's 5 ml.
It's 5 mLs. Make sure you are careful with your concentrations, okay? The other ones that we had done so far were all in 1 ml, okay? This is 375 in 5 mLs. So So these cross out. What am I left with? mL. So I know that I've finished with the right math. So 0.4 times 1,000 times 5 divided by 375. What is it?
It's 5.33333.
5.3333 forever and a day, right? Can I put that dose in a syringe with that arrow over it?
No.
No, I gotta round it, right? So if I'm using something over 5 cc's, over 3 cc's even, I'm gonna be using a larger syringe. So let's round it to the single decimal place, which would be
5.3.
So what's my answer gonna be?
5.3 mLs.
5.3.
mLs.
Yes.
Half credit.
Half credit. You almost got half credited right now. Okay, so 5.3 mLs. Okay. Does that work? You feel comfortable with that?
Does it look right? Yes.
Yeah, looks good to me. Okay.
You're reasonable.
That's a reasonable amount, yes. All right, unless you have any questions, you guys are free to go.